today we will see in this lesson electrostatics, whatever we have completed, we will summarize and see a review of it. First, in this lesson, electrostatics, what we are going to see about the electric charges which are at rest. The charges on the rest charges in this lesson we are going to deal with it and the forces acting on those charges. So, charge rest and the charge act on the forces in the lesson. So, first charges at rest. The charges which are at rest, that we call it as electrostatics. Statics na rest. The charges about rest. Now, thus if you see the charges about rest, you see the history how the charges are produced in an object. The first discovered by Thales. Thales is the first that discovered Pannara in the 600 BC when he rubbed amber with fur. Amber fur which rub pannumbodhu, he just noticed some. It can start at amber attracted some lighter objects like bits of paper. By this only the history of frictional electricity came into existence. Then in the 17th century, William Gilbert, he noticed that not only amber rubbed with fur but also glass ebonite also exhibited this property. Glass or ebonite in the property which one of attracting some lighter objects when they are rubbed with suitable materials. Then the classification of electric charges was told by the American scientist Benjamin Franklin. Then we will see first what is meant by charge and what are the two types of charges. So here in this there are two types of charges. One is positive charge and one is negative charge. Positive charge every produce an object as an atom, it is electrically neutral. But when it loses some electrons, when it is rubbed with a suitable material, for example glass and or a silk cloth vechchu rub pannittu. So this glass will lose some electrons. When it loses, other electrons it will give to the silk cloth. Glass silk cloth vechchu rub pannumbodhu glass la irukra electrons it is gone to the silk cloth. Glass when the electrons enga poidum, silk cloth ku transfer aidum. So this glass loses some electrons. Now I can say this glass has positive charge because it is losing the electrons. The number of protons in this glass will be more. So I can say the glass is having positive charge and the silk cloth will be having equal amount of negative charge. So this is the way how we can charge an object or a body, whatever it may be. So the charging I can produce by friction. By friction method charges are produced pannalam, by induction and by conduction also. First we will see by friction eppadi charges are produced in an object. Then classification of positive and negative charges. Then we will go for the properties of the charges. Properties of the charges, first we will see what are how like charges. Like rendu like charges in one positive charge, one positive charge. Rendume ore mari charge anda will they repel or attract? Definitely they will repel. Rendu positive charge irundhalum repel pannum, rendu negative charge irundhalum repel pannum. If one positive charge and one negative charge irundha, they will definitely attract. So that was the first property we are going to learn in the properties of electric charges. Like charges repel and unlike charges attract. A small experiment is also we have seen about this. Like charges repel and unlike charges attract. Then here, then we will go for the quantization of electric charge, law of conservation of electric charge and additive nature of electric charge. Quantization of electric charge, how to find out the total charge of the system? It is given by the formula Q equal to integral multiples of the least amount of electric charge E. The E is nothing but your magnitude of the electron whose value is 1.6 into 10 power minus 19 coulomb. Then here second one is the law of conservation of electric charge. In a total system, the number of charges will be constant. That is before and after decay. If we see the number of charges in an isolated system, these charges, total number of charges before and after will be the same. Very good example. Then uranium 92 with mass number 238. When it decays by emitting an alpha particle, it gets transformed into thorium. Its atomic number 90 and mass number 234. So this is the amount of charges. See here, before decay charges plus 92E. 92E inga 90 plus 2 92. So before or after same amount of charges I can say this is a very good example for law of conservation of electric charges. Then additive nature of electric charge. Additive nature of electric charge means in an isolated system or system charges. It may be positive charge or it may be negative charge. Then how to find out the total net amount of charges present in a system? It is given by the vector sum of the charges present in the system. For example, there are two charges present. One is minus 5q, the other one is plus 2q. How to find out the total amount of charge present in the system? One minus 5q irukku, one plus 2q. You have to take the vector sum. So minus 5 plus 2 is your minus 3q. So this one gives you the total amount of charge present in an isolated system. Then we will go for the force of attraction or repulsion between any two charges. There are two charges present. This man Coulomb is the first person to give how will be the nature of the forces between any two charges. This we call it as the Coulomb's law. He told that the force of attraction between any two charges will be directly proportional to the product of the charges and inversely proportional to the square of the distance between them. So here this K we call it as the constant of proportionality. Its value is 1 by 4 pi epsilon naught. This is nothing but 9 into 10 power 9 Newton meter square 3 power minus 2. Where epsilon naught is called the permittivity of the free space. Its value is 8.854 into 10 power minus 12 c square n power minus 1 m power minus 2. Then the definition of 1 coulomb we have seen. 1 coulomb is nothing but the unit for charge. Then what is in the electric field? Electric field are nothing but your electric lines of force. So what are electric lines of force? These electric lines of force are nothing but straight or imaginary line paths. Just how a unit positive charge tends to move in an electric field, that we call it as the electric lines of force. So in the electric lines of force, what are properties? And the properties படிச்சிருக்கோம். Then we have seen in an electric field and electric field due to a point charge. ஒரே ஒரு point charge இருந்ததுனா அந்த point charge சுத்தி electric field எப்படி இருக்கும்? It was given by the formula E equal to 1 by 4 pi epsilon naught q by r square. So what is this formula? This is nothing but the electric field due to a point charge. ஒரே ஒரு charge இருந்ததுனா எப்படி இருக்கும்? There are two charges. அது ரெண்டு chargesக்குள்ள force of attraction or repulsion எப்படி இருக்கும்? It was given by Coulomb's law. These two formulas are very very important and the constant values. Then we will go for the electric dipole. What is a dipole? It is nothing but the two equal charges and they are opposite and equal charges. When they are separated by two small distance, here I have one charge plus q, here I have another charge minus q. So the magnitude is same, but these two charges are opposite. So two equal and opposite charges, if they are separated by a very small distance, when the charges are same magnitude but opposite charges. அது ரெண்டுத்துக்குள்ள distance வந்து it's very small. The constitute இதுதான் நம்ம என்ன சொல்றோம் dipole சொல்றோம். What happens? How to find out the magnitude of this electric dipole? That is given by electric dipole moment. Electric dipole moment என்றது to find out the magnitude of the electric dipole. That is small letter p தான் அதுக்கு symbol equal to q into the distance between them. What is here 2d? Nothing but the distance between the two charges or distance of separation between the two charges. P equal to q into 2d, the vector quantity. How it acts? This electric dipole moment is a vector quantity. So நமக்கு direction தெரியணும். இந்த electric dipole moment minus q ல இருந்து plus q க்கு act பண்ணும். So you have to represent the direction also. Unit என்ன இருக்கு? The unit for dipole moment is Coulomb meter. Then electric field due to a point charge. What happens? If this electric dipole is placed in a uniform electric field. So electric field due to a dipole at a point on its axial line. So here the point lies on its axial line. When the point lies on its axial line, அதோட electric field எப்படி இருக்கும்? We have seen that also is given by E equal to 2p by 4 pi epsilon naught r cube. Here the direction of this electric field due to a dipole on its axial line is the direction of the dipole moment. That is, it acts from, this E will be acting from minus q to plus q. That is in the direction of the dipole moment. Minus q to plus q, or we have also written the direction along BC. So up to this we have seen in this lesson electrostatics. All the constant values are very very important and all the formulas. So far என்னென்ன formulas படிச்சிருக்கோம், என்னென்ன constant values, the formulas are based when you will be getting some 1 mark or 3 mark problems. Then all the examples whatever given for your properties and everything you should be thorough. So all this you will be getting in 1 mark. Then now we will go for What happens to this electric field due to a dipole at a point on its equatorial line?